Good afternoon. My name is Helena Dawsonay. I'm a master's student in environmental engineering, and I work full-time at the Florida Department of Environmental Protection as an emergency responder and an inspector for their wastewater and stormwater programs. Prior to working for DEP and enrolling at UF, I actually got my master's in public health from LSU, which kind of led me to my topic for this class. I'm going to be looking at applications of activated carbon in public health, primarily focused on lead and mercury removal. Now, the reason I chose lead and mercury is because these are kind of hot topics in my study program in New Orleans. There are lots of old homes there. In old homes, your main source of lead contamination is going to come from lead pipes, lead paint, lead fixtures. But even if you are in a newer home, there's still a risk if you live in a highly industrial area, such as New Orleans and Louisiana. We get a lot of industrial wastewater that comes down our river. And so looked a lot at that. And then mercury is another common pollutant because it's naturally occurring. It can leach from the soil to begin with, but it's also found in a lot of common household items and some not so common actually, but for batteries, old thermometers, barometers, blood pressure cuffs. And in some cases, you'll see just jars or vials. You'll find them randomly depending on, there was a previous homeowner, because they're believed to have, some ritualistic powers and influence there. And again, in your industrial wastewater, you can be impacted once it contaminates your source of drinking water. Now, the reason these is a concern is because there's no safe concentration of mercury or lead. There's two routes of exposure primarily for both of these toxic heavy metals. With lead, you're primarily going to see exposure due to ingestion, which would be your drinking water. A primary example of that is Flint, Michigan, which I'm sure many of you are familiar with. For mercury, you have two different routes of exposures to be concerned with. Ingestion is one, and that is for your organic mercury. That's due to bioaccumulation in seafood. So if you like seafood, that's where you'll get your exposure there. With elemental mercury, which is that shiny silver stuff that we saw in the previous slide, you have to be concerned with the vapors that come off of that. That's what's toxic, is those vapors. So your route of exposure is inhalation. The health effects for both exposures is serious, and it's mainly on your development mentally and physically. So that's what makes children and fetuses high risk. Again, there's no safe concentration. The Safe Drinking Water Act actually monitors both. There's an action level and maximum contaminant level for both, and as you can see, they're extremely low. So my paper is going to focus on activated carbon at home, so point of use methods, which is your carbon filters that use granulated activated carbon, or if you've got a fancier system, you'll probably see some fixed bed absorbers as well. So I'm going to look at those methods, do some research there, but I also wanted to look at activated carbon, the use of mercury vapor capture. So that's like your fabric filters, and I know those are used in mercury vacuums, but I wanted to understand more so how the fabric filters work and how they're designed and manufactured and whatnot. There are some point of use case studies already out there, so I did want to include a review of those case studies in my paper just to give everyone an idea of what has worked and hasn't worked and where we're going. And with that, with where we're going with the research and innovation, there's chemical activation that's being looked at more in manufacturing the carbon to increase the efficiency of removal for mercury and lead, and electroabsorption, and then injection rates are also being looked at on fabric filters to increase the removal rates there. So I wish you all luck on your paper and the rest of the semester. Thank you.